Alright guys, so on this video what I'm going to do is help you guys with number 7 of your homework, okay? Um, Pretty much in this problem, it's going to give you a piecewise function, right? But it's going to ask you to find the domain, locate intercepts, graph the function, um, and all that good stuff pretty much, okay? So I'll go through that with you guys. Um, So yeah, let's go ahead and get started. So the cool thing about piecewise functions, when it comes to domain, it usually already gives you the domain on the side, right? Because these are all of the x values we will be using, okay? So this part right here is the key. So all of this together is your domain pretty much, right? So it tells you all of the x values we are using, okay? So let's go ahead and, so what I like to do is draw a number line, okay? And I like to start with the first one. So let's look at what it's telling us. So it's saying our x values for this first one are from -4 to 1, right? So that's why I'm going to go ahead and do -4. And I'm going to put 1 right here. Okay, and it's telling us that x is including the -4, so I will go ahead and put a dot right here. And it's going to go all the way to 1, right? But if you guys notice, it's not less than or equal to, so it would be an open circle for me right there. So all of this so far is in my domain, okay? And this is just for the first part, okay? The next part tells us if x is equal to 1. So in other words, when x is 1, that's going to be in our domain as well. So now we can actually fill in this circle right here. And then the last one is telling us also our domain for this function right here would be when x is greater than 1. So then that pretty much says everything beyond this 1 right here, right? So pretty much this will fill in everywhere. So pretty much you guys can see here that our domain starts right here at -4, and we're including it, so that's why I have the bracket, and it's going to go all the way up into infinity, okay? A lot of people were actually asking me the difference between these two symbols. So just keep in mind, this bracket means that you are including that number, okay? And then so the parentheses would mean not including, okay? Um, the you might notice that the infinity signs always have these. That's just because they're technically not a number, so there's no way to define it. So we just always put it as a parenthesis. So that's just kind of basic when it goes to infinity, okay? But when it has actual numbers, it has big meaning when you have a parenthesis or a bracket. So this bracket means including, okay? All right, so let's go ahead and plug this into our equation. Let's see what we get, right? So let me get out of this. So we said our domain is from, let me see if I learn how to use this, from, nope, not that, -4, comma, to infinity, and then close parentheses, right? Let's see if that's right. Well done. Yes, thank you. I know. Cool. So that's pretty much your domain, right? So you want to write it as interval notation. When they say interval notation, that always means like that, okay, with the brackets and the parentheses. All right, so how can we find our intercepts, okay? For this, you can do the techniques that they show you online, but what I prefer to do is just, we're going to graph it anyways, so we might as well just graph it and see if we can um, just get the intercepts from there. So let's go ahead and do that. So let's go ahead and graph this. It actually might be better if we graph it using the program, right? So let me see if I can skip this. Ooh. Or let me just figure this out real quick, actually. So any intercepts. What would a good intercept be? Well, whatever. Let's just do it the way they want us to do it. Sorry. So, okay. If we want to find intercepts, you guys remember what we do, right? So if you want to find um, your x, oops. Oh, I forgot I'm not on the dictation thing. Okay. So if you guys want to find intercepts, remember we want to find, so like let's say if we want to find x intercepts, remember we plug in 0 for y. So we're going to have to do this, but for all of our functions, right? So let's do it for our first function. So y is equal to x plus 5. So if we want to find the x-intercept, we plug in 0 for y. So 0 equals x plus 5, right? And if we solve for x, we end up getting x is equal to negative 5. So we know at x equal to negative 5, we get a y-intercept, right? Now let's go ahead and go to do our y-intercept here, see if we have any. So if we plug in 0 for x, we end up getting y is equal to 5. The only thing with the piecewise functions is that you do have to be very careful. So notice here that for the first function, we do actually have 0 as our domain, right? So we can plug in 0 for x. So this would be okay still. But if our domain did not include 0, then obviously this wouldn't be our y-intercept, right? We wouldn't even be able to test it because it's not even in our domain, right? So be careful with that. This one as well, we have to be careful that whatever our answer is, it has to be in our domain, right? So let's actually double check this. So x is equal to negative 5. Is negative 5 in our domain here? No, right? We see that it stops at negative 4, so this is actually not an x-intercept, right? So far we've only found a y-intercept for the first one. The second one we have, we can pretty much see that we're not going to have an x-intercept because it's a horizontal line, so we won't have x-intercepts for sure. And then the y-intercept, we would have a y-intercept, but in order to have a y-intercept, the value of x has to be 0. So this one also wouldn't be the case because this only happens at x equal to 1. So because it doesn't happen at x equal to 0, this wouldn't be considered a y-intercept, okay? And the final thing would be to check these as well. So for x-intercept for the last one, we have to plug in 0 for y, so let's write out the equation first. So we plug in 0, we get 0 equals negative x plus 2, so we get x is equal to 2, okay? So we'll have to check that right now. So is this answer x equal to 2 in our domain? Yes, fortunately, and it is in this case, right? So if x is greater than 1, which this is, this should be an intercept, so that would be 1. And then for the y-intercept, we also have to do it as well, just to be sure. So we'll do y equals negative x plus 2, and then we plug in 0 for x, so y equals 2, right? Same thing here though, we have to double check to make sure 0 for x is in our domain. Unfortunately, this one is not in our domain, so this one wouldn't be an intercept. So in this case, we find that we only have intercepts at 0 and 5 for this one right here, and then this one would be at 2, 0. So we only have one x-intercept and one y-intercept, okay? So let's go ahead and plug those in and see if those are right. So 2005, 2005. So 2, 0. And then be sure to put a comma, because they tell you right here, use a comma to separate answers as needed. Okay, so don't get mad at the program if they told you what to do. And then 0, shoot, I forgot the answer. 0, plugged in 0, it's going to be 5. Yeah, so 5. Oops. Comma 5. Okay, and let's just double check that. Hopefully I remember the answers. Yes, so 0, 5, and that's it. Those are your intercepts. Okay, let's continue on to graphing. Okay, oh, so cool. So here, luckily, they actually give you the graphs below. So all you got to do is just pick the one that works, okay? So first things first, if they give you the options, you can go ahead and use this to eliminate a lot of the answers, right? So you know at x equal to 1, your answer has to be 9. So let's check. So for this one, this first one, at x equal to 1, is the answer 9? No, right? We don't have an answer here, so we automatically know. The first one's not right. At this one, at x equal to 1, does our answer have 9? Nope. So we will ignore that one as well. What about this one? At x equal to 1, is our answer 9? Wait, 1, 2, 4, 6, 8, 10. Okay, yeah, so this is 1 in between. So yes, this actually does have it, so we will consider this one. And then let's just double check this one also. Yes, this one also has it at 9. Okay, so we know it's going to be between these two. We know it's not going to be A or B. So for now, we just got to check, we can just check the domains, right? So let's just make sure the domain for, how can we do this? So we can double check the domain. How can we double check this? I'm trying to do this without graphing it, but we might have to graph it anyways. Okay, so let's go ahead and graph these. So a lot of you guys already saw me helping you guys graph this stuff, but let's go over it again. So if we want to graph these things, it's going to be pretty much like graphing normal equations. It's just that we have 3 different ones, right? So let's go ahead and graph this first one. So since our y-intercept is 5, we're going to graph it up here at 5. And then our slope is 1, 1, so it's going to be kind of like that, okay? And so we'll have like a line that looks like this, okay? For right now, it's just going to be a dotted line because we will fill this. I'll show you guys right now why I'm doing a dotted line, but for now, it's going to be that. At x equal to 1, we have our answer is 9, so that would be about right here. So that should be the dot that we have. And then the last one is going to be at positive 2, so 1, 2. And then the slope is negative 1, 1, so 1, 1. Should go like right here. I know my line is horrible, sorry guys. Okay, so the key here now is that we need to figure out from where to where do our functions matter, right? So for the first function, we have it right here. It tells us that we only care about our function when it's between negative 4 and 1. So we're going to go to x equal negative 4 and x equal to 1. And we're just going to fill in the stuff between there. And be Be aware that it might not be filled in or not, okay? So for this line, we would pretty much fill in this stuff right here. Okay, so we would ignore the rest of this line right here. We don't need it because it's outside of our domain. Then of course our dot's right there, and now let's look at our other ones. So whenever x is greater than 1, so we gotta go to where it's right here. It's gonna be an open circle because it's just greater than it, and then we would just fill down right here, right? So you can see that here they shouldn't be connected, right? Because our lines are a little separated like that. So we know it's not going to be D. We know it's going to have to be C. So let's go ahead and plug that in. And I think I'll make a more detailed video right now about graphing, just in case, okay? So let's check our answer. Done. Awesome. Find the range. So here we just got to look at the range. So in other words, what's our lowest value to our highest value, right? And then keep in mind that we have a point. So then our lowest value would be negative infinity. So our domain starts at negative infinity. and it goes to, without stopping, our range goes from negative infinity. It connects here, so we're okay still, and it stops at 2, 4, at positive 6, but we're not including that 6 because it's an open circle. So it stops at positive 6, but we're not going to include it, so that's why we put a parentheses. Comma, comma, oh well, I think I forgot how to write this single point. Let's try something. What if we just wrote so we're including the point of 9, right? That's our y values. So let's try this. 9 to 9. And I have no idea if this is going to be right. Let's check. I don't remember if this is right. No. Okay. How the heck do you write that 9? To 6. Oh, union. Duh. We can't do commas. I'm sorry. Union 9, 9. Yay. Okay, cool. Yes, that was right. So if you have a single point, you just represent it as the same number, and then you make sure that you're including it everywhere, okay? And don't forget this union sign. You need that to continue your domain.